Well, we are going to get started just a couple minutes early. And thank you, Dr. Powell, for coming to the Schenck School tonight. So it is my pleasure to introduce Sarah to all of you. Sarah Powell is a professor at the University of Texas, Austin, and Associate Director of the Meadows Center for Preventing Educational Risk. She's on a mission to make math more accessible, especially for those who experience it differently, and I would say that's probably most of us, diagnosed or not. She leads multiple research projects, including IES-funded grants on word problems, math interventions, and teacher collaboration, and she is shaping the future of math leaders in education and researchers through a doctoral leadership grant. She even, in 2019, received the prestigious Presidential Early Career Award for Scientists and Engineers. So she's a bit of a math rock star here. And she knows that none of this happens in solo by herself. And she frequently sings the praises of the teachers, the students, and the other researchers that she has the privilege to work with. For sure. So thank you again for coming to the Schenck School. Take it away.
Thank you very much. Thank you. Thank you. Wow. Well, welcome. Thank you for coming out on this super rainy night to talk to me about mathematics, or I guess I get to talk to you all about mathematics. So as introduced, my name is Sarah Powell. I am joining you from the University of Texas at Austin. It's my contact information. Yeah, there we go. Very nice. So I do like to hook them. I'm originally from Ohio, so I'm an Ohio State Buckeyes fan, which I know probably doesn't bode well here in Georgia. Yeah, so I wasn't going to bring it up, but you brought it up.
Well, she converted.
Okay, all right, there we go, yeah. But I will just tell you just very little bit about myself. So I am a teacher by generations. This right here is my great-grandmother who is teaching in Kansas before the turn of the century. This is my grandmother, Rannells, which is my middle name, teaching in Southern Ohio with kids who didn't wear shoes to school. And then these are my parents who were also both teachers, and they always love it when they do not look like this anymore, but they were English teachers. And then I became a kindergarten teacher. I taught in both Kentucky and Tennessee. And then I graduated from Vanderbilt University. I worked with Lynn Fuchs, who's right there, did a lot of work with her in the area of math intervention. And then 12 years ago, I took a job at the University of Texas at Austin, and I built a team there where we just focus on thinking about what's really important for the learning and teaching of mathematics. And so currently I do have some funded projects, and we hope that those will continue to be funded, where we work with IES project where we're working on word problem intervention. So tomorrow with the teachers here, I'm going to be talking to them about what's really important for word problem solving. And we're going to dig into a program we have called Pirate Math Equation Quest. We have a 4th and 5th and 6th grade fraction intervention project called Scale. So I work on that, where we provide fraction tutoring to kids in schools. We have a middle school teacher support project called STARE that we work on, not only in Texas, but in Missouri and other states. We have a grades 4 and 5 teacher support project called Spiral, also IES funded. This is also IES funded. And then we have a project that I work on with Elizabeth Stevens, who I know was here last year, that's IES funded, which is a math words program around math vocabulary. And then I also support doctoral students who are focused on math. So everything I do is focused on math, which is just an absolute joy to be to a dyslexia school about that. And so I thought we would talk for just about an hour or so about some things that are related to literacy in math. But I'm going to not do all of the talking. So I just want you to say hello to a neighbor, and I want you to tell them, why are you here tonight? What is your interest in math? And I'm going to ask you to talk to them a few times tonight. So just 30-second hello. What about math is interesting to you? All right, so when we're thinking about support for students in mathematics, I like to think about, and I should never let you all talk to each other because then I'm never going to get the room back, right? No. But when we're thinking about support in mathematics, I like to think about putting together a really strong instructional platform for students. And in math, there's a lot of really great resources out there that identify some of the research validated, or we might call them evidence-based practices in math. This practice guide here from the What Works Clearinghouse, just released just a few years ago, is how do you help students who struggle in math? Do any of you know any kids who struggle with math? Yeah, all right. And in this practice guide, they identify 5 really important components to put into that student's instructional platform. And I'm going to talk about 2 of them tonight because they're literacy focused. And that is the first one, which is about we really need to help students understand this language of math. And it's this last one, we need to help students understand how to set up and solve word problems. Because students show off what they know about math through problem solving. So it isn't can you add 26 plus 26? It's can you read this text-based scenario? Can you find 26 and 26 in there? And then do you understand that you're going to add those numbers together? So it's a very complicated task, and it's complicated because of the language or that literacy that's involved in that understanding of math. And so as I put together this visual when I'm thinking about showing this with groups of teachers, of which I know some of you are, if I'm thinking about what's my good platform for math instruction, well, am I teaching vocabulary in mathematics every day? And then if I continue, I'll talk about some of these things tomorrow. Am I using representations to help students understand math? Am I doing that every day? Am I modeling and practicing in math? Am I building fluency in math? And then every day, am I helping students with their word problem solving? And this is true even at kindergarten and first grade. We might be orally presenting stories and working with manipulatives, but we're really ratcheting up students' word problem skill in those earlier grades so that as they get to word problem solving more formally, usually around grade 3, they have a really strong foundation for that word problem knowledge. So I thought what we could do tonight, and we can also talk about other stuff because it is a small group, so if you want to talk about something else, let me know. But I thought we could do vocabulary and a little bit on word problem solving. So good to kick off with vocabulary? All right. And I think when Liz was here, she probably did talk. Did she talk about math vocabulary? Mm-hmm. Yeah? Okay, good. All right. I'll have to tell her good job on that one. All right. So just a little bit about why vocabulary is an important part of the instructional platform. These are just some citations from research. The first one, which is not going to be a surprise at all, but there's a significant relation between math vocabulary and math performance. Surprise? Not really. And the most significant correlation we see is between math vocabulary and word problem solving. Definitely not a surprise, but it is a pretty strong relation between those 2 things. And we see that math vocabulary, the knowledge the students have with math vocabulary, it really starts very early. David Papura and colleagues, they work with 3-year-olds and 4-year-olds. And do you know what 3 and 4-year-olds do in math? They don't actually really work on math. They work on math language. The earliest learning of math is through language. And if you don't understand that language, whether that's, oh, you have more, you have less, I'm next to, I'm walking away from you, away can be this spatial language. And if you don't have the language of 1, 2, 3, it's really difficult to count 1, 2, 3. And so we see that early math language is very related to your overall math performance. And then throughout the elementary grades and into the middle school grades, we see that when students struggle with math, they often show lower math vocab performance. So that means we have to make sure that we're emphasizing that vocabulary of math every day to help students have that strong understanding of math. Now, sorry for my dark slides here. That's blue was probably not the best choice on the dark blue background. But I want you to just look at this, and these are math vocabulary counts across grades K through 8. And what we've done is we've looked at textbook glossaries, and we've tried to figure out, well, how many math vocabulary terms is a student responsible for knowing at any grade level? So in kindergarten, first, second grade, your students in those grade levels probably need to know about 110 to 150 math vocabulary terms to be a full participant in the math classroom. Think about that, 150 terms. In third grade, we see a really large increase here. Why? What happens in third grade, math-wise? New stuff. What's new for them? Multiplication, division, and fractions, area, perimeter. All right, yeah. I mean, just in fractions alone, we could probably come up with 50 different terms. And so if students don't understand that language, they're not going to understand the stuff about fractions. And then by the time we get to sixth grade, you've got some sixth graders here, they may need to know over 500 math vocabulary terms to be a full participant in their math classroom. And how do they participate? Students listen to math vocabulary. They have to speak to answer and share ideas. They have to read. That's a big understanding of math vocabulary. And they also have to write. And all of these come back to, do you understand what a parallelogram is, what numerator is, what more means, what ZERO? If you do not know that, and if you don't know how to spell it and how to write it and how to read it, it's going to be pretty hard to fully access the math that you are participating in. Now, if I'm thinking about some of the students in your school, I wanted to think about, well, why might some students have difficulty with math vocabulary? So there's some common reasons here. I'll just share these, and then I'd like you to talk with your now best friend around you of like, what do you see are some of the difficulties that students have with math vocabulary? So for some students, they hear math vocabulary terms, maybe like degree. And that word has different meanings depending upon whether you're in a math classroom or outside of the math classroom. So if I say the word degree, what pops into your head? Heat, temperature, what else? Angles, graduating, importance. Maybe some of you use a deodorant called degree, right? So right there, like if you say the word degree in the classroom, you could have 5 kids have 5 different interpretations of that term. Students also hear math terms that they might hear in math and outside of the math classroom, and the math meaning is going to be more precise, even though they kind of have a similar meaning. The one I always bring up here is difference. So I live in Texas now, and so if I asked you all, what is the difference between Texas and Georgia, we'd have 20 different responses. And they'd be funny, and you guys would be cheeky and all of that. But if I asked you all, what is the difference between 6 and 2, hopefully all of you would tell me 4, right? That's more precise, but in all of those examples we're comparing. There's a lot of math terms that have more than one meaning. You already gave me multiple math meanings for degree. What about if I say square? What are you thinking about? Shape. What might another kid be thinking about? Square root, yeah, and you're squaring a number. And then there's also a lot of math terms that students have only ever heard in math. So they've come into your classroom and they probably have not run into parallelogram in their real life. And so a lot of these terms are really important for instruction to make sure that students understand that language. And then continuing, I'm not going to spend a lot of time here, but there's some terms you might say sum, S-U-M, and kids are interpreting that as S-O-M-E. There's some math terms that are related but actually have very distinct meanings, and so kids may confuse those. There's some math concepts that are talked about in more than one way, and there's a lot of informal language that we might use in replace of that formal language of math. And so these are just 8 reasons that students might have some difficulty with math vocabulary. Why do you think some of either your child or some of the students that you support, or just students that in general, why do you think they might struggle with math vocabulary? Just have a 30-second conversation with your neighbor, and then we'll get into a few examples of this here. All right, so as you think about some of the reasons that students might have difficulty with math vocabulary, 2 big ideas that we are often thinking about as we're thinking about how do we design instruction around math vocabulary, we think about these big ideas. First is that we, as teachers or adults, need to use formal math language, and the students need to use the formal language of math. And then second, once students know those formal terms, they have to have good, precise definitions of those terms. So I'm going to give a few examples of each of these, and then I'm going to ask you to talk to one of your friends around you. So this kind of gets to the example that we were just talking about here. So here I have a comparison. And informally, in red, I could talk about, oh, I've got this alligator that's super hungry and chomps this bigger number, right? But formally, I want to talk about what's going on here. 6 is less than 9, or 9 is greater than 6. The formal language would be greater than or less than. Instead of talking about this number and asking what number is in the tens place, technically, the formal way to be talking about this is what digit is in the tens place. Instead of talking about the addition here and say, oh, all I'm going to do is carry the 1. That would be informal language. Instead, I could talk about regrouping or trading or exchanging. Instead of reading this fraction as having this top number and bottom number, in actuality, a fraction is a single number that's represented by a numerator and a denominator. So let's make sure we use that language of numerator and denominator. Instead of reading this as I would write it with my pencil, 4.7, let's talk about the place value here, 4 7/10. Instead of describing this as a box, this is technically not a box, that is a square. Instead of talking about that as a corner, that is not a corner, that is a vertex. And instead of talking about this as having a long hand and a short hand, technically we have a minute hand and an hour hand. So there's a lot of examples where we can take this informal language, and it's cool that kids can use this informal language, but we also need to make sure that they understand that more formal language of math. And so can you think of one or two examples where instead of using this informal language, it would be great if our kids said it more formally? Talk to your friend around you and see if you can come up with a good example. And so then once students are learning these formal math terms, then we need to make sure they actually understand these terms. So it isn't enough to know numerator. You have to also know what numerator means. And I know that this seems rather simplistic, but we see that a lot of students don't always understand the formal language of math. And then some students can use the terms, but not actually tell you what they mean. And why is that? Well, a lot of times we see that the terms that students confuse often are terms that they hear about the same time. So they might hear them within the same unit, maybe within the same day, maybe even within the same minute. A very common one across states is kids confusing factor and multiple, when in fact these mean very different things, and we want to make sure that students understand the differences there. What about when we're talking about fractions? Could every student here in this school tell you the difference between a unit fraction and a proper fraction, or a proper fraction and an improper fraction, or an improper fraction and a mixed number, all right? There's so much here, and they may know the term improper fraction, but could they actually give you a precise definition of it? What about when it comes to algebra? I know this is probably going a little far for some of your students, but what is the difference between an equation and an expression? Those are technically different things, and we need to respect that language and have the students understand the differences there. Geometry is an exercise in vocabulary. And so if students don't understand geometry vocabulary, it's going to be really hard to do anything in geometry. So here just are the quadrilaterals. There are overlap among some of these terms. Some of these terms are distinct. But could students in this school tell you what a square is, tell you what a trapezoid is, tell you what a rhombus is? What about how we name angles? What's the difference between an acute angle and an obtuse angle? How about how we name two-dimensional shapes and three-dimensional figures? Could students use all of these terms with the precision that's really required to show that they understand these terms? And then here are names for three-dimensional figures. I have seen many students interchangeably use prism and pyramid. Have any of you ever seen that? These are very different shapes, but they both start with P. That could be confusing, but there also might be other reasons. But we need to make sure that you do understand what a pyramid is versus what a prism is. So what are some of the terms that you see students confuse? Or maybe think about terms that students need to use with precision. I'll just give an example, numerator and denominator. Do students actually understand the difference between those terms? Talk with your friend and see if you can come up with some examples there. All right, so then as we want to make sure just that students understand this formal language of math, and knowing that at many grade levels there's hundreds of formal terms that students have to know, and then they have to know hundreds of definitions to go along with those terms. So this is a lot of learning, and we really haven't even talked about anything that resembles math like a number, all right? And so what are some of the ways that we can do this? So a lot of these strategies that we can use to help supplement students' math vocabulary come from language arts. So we can use different graphic organizers here. Here we're explaining what horizontal means. Here we can use different types of semantic maps. A project that I'm working on with Elizabeth Stevens, we have a math words project right now. We're developing these semantic maps for common math vocabulary terms across grades 3 and 4. So here you can see we've got the term, we also have the symbol when that's necessary, and then definitions, related terms, visuals, and an application of that. So are there terms where some type of map like this would be helpful for students? And this is an abbreviated map that we're also working on there. Word walls are great, but they're only as great as they are as often as you refer to them. So if they're just over there behind that column and I'm not using them ever, I would say don't even bother with the word wall. but they need to be referenced often. And many times this is a different types of word walls, but you can see we see it got the term, usually some type of definition, and then often some type of visual that helps us to take some meaning as to what that term actually means. Flashcards are a nice way to review vocabulary. We have a grades 4 and 5 fraction intervention that we run right now. And at the beginning of the intervention, the teacher has fraction terms on a ring, and they just go over 5 just in about 1 minute before they get into the intervention. So let's say, okay, what are we talking about today? Oh, let's say this term together. Okay, whole, what does whole mean? Oh, we're also using equal parts. Let's say equal parts together. What does equal parts mean? What is numerator? Let's say that together. What's your definition of numerator? So if you just have that real quick review before we get into the intervention, then when I say, hey, today we're going to take that whole and divide it into equal parts, I've had that nice vocabulary review very recently. Glossaries are great to use here. This is an example where we have students create their own glossaries with different alphabetical pages. In Texas, we have a large number of Spanish speakers, and so we will actually create some of our math vocabulary. But this is our grades 4 and 5 that's in Spanish and in English. Anchor charts are great, so a lot of the visuals that we're using in the classroom can be a good opportunity to spotlight math vocabulary. We can play games. This is a game that we've done at grades 3, 4, and 5 with different types of geometry vocabulary. And we will actually hold up the shape or figure. We won't say it. Students have to look at it, interpret it, and then figure out, oh, that was a rectangular prism that she held up, and they would mark that on their bingo board. This is a memory matching game where I'm really working on the vocabulary related to unit fractions. So can I read 1/4 and then match that to the visual that represents 1/4? These are some of the games that we're using in our math words here. We've got like math term mystery, perfect pair, and then we've got some partner games. And we are going to have these on our math words website probably by the summer. So you'll be able to freely download and use some of those as well. Discussion is great. So, hey, turn and talk to your partner about this. But it's better to give students some target terms. When you talk to your partner, I'd like you to use at least 3 of these terms in your discussion. And here's one of the things where we have like turn-in talks where students get to look at visuals and then they have to use these terms in their explanation of what's going on in the visual. Math writing is a really good way to emphasize math vocabulary. Math writing can also be supplemented by a word or term bank where students can use 3 or 5 of those terms in their writing. This is an example from Math Words where we have a story slam. So there's a story here, and then students have to choose which term goes in the blank space. We found that kids really are enjoying the story slams. Read aloud storybooks. I'm sure there's hopefully a few dozen math-focused storybooks in this library. But these are all really good launching points for math vocabulary discussions. And many times when I've talked to teachers about storybooks in math, we think about counting books, right? But these are books about, these are both about 3-dimensional figures. This is fractions, place value and 0, and this book's about multiplication. And we actually have books all the way around like Pythagoras and the Pythagorean theorem that are very storybook and very visual and introduce a lot of really great vocabulary to the students. And then technology can also be used to help supplement students' math vocabulary. But the idea of math vocabulary that's important is that we're doing this so that students learn math vocabulary. So I can sit up here all day long and say parallelogram and trapezoid and rhombus, but until the students are using those terms, writing those terms, reading those terms, and understanding what those terms mean, you know, it's helpful if I know the terms, but it's more helpful if the students know the terms. And so what are the ways that we can bake math vocabulary into every minute of math instruction? Those are the things that we really want to think about for our students. And so I'd like you to just quickly turn and share maybe an activity that you have either found helpful or maybe that you would find helpful for building math vocabulary with students. So just about a minute there, and then we'll turn our attention towards word problem solving. All right, so as we think about this instructional platform, again, I like to think about this as this jumping off point for math instruction. I would say that if I'm planning math instruction for students, I want to think about how am I supporting students' vocabulary? And I've got to think about that every day. It's why it's actually first in the instructional platform. If you don't understand that language of math, it's going to be very hard to be successful in the math classroom. But then as we build in, we bring in representations, we want to model and practice in math, we want to do fluency building in math. But then the other thing that I think is a real big hot topic related to literacy in math is how do we help students set up and solve word problems in math? So I'll just spend the next few minutes talking about that, and then we'll finish and have a brief discussion and answer some questions. So word problem solving. Here's some of the research around word problem solving. So one of the things that's not very effective when it comes to word problem solving is using this keyword strategy, and I'll give an example of this in just a minute. And then, what do we do about word problem solving? If that doesn't work, well, there's two things that we see pretty much time and time again are really important for word problem performance. First is using this metacognitive strategy, or I like to call that an attack strategy. That's just a general way of working through a word problem. And then second is focusing on what we think about as the word problem schema. Schema is a fancy word for problem type or structure. It's just really, it's the concept. What's the concept going on in the word problems? And if there's any conversation in math, it's always about how do we help students develop conceptual knowledge? Well, there's deep conceptual knowledge embedded within every word problem that students ever set up and solve. And so if we can really help students focus on that, we can get at the heart of what's actually going on in many of these word problem stories. Now, word problem solving is complicated because there's a lot that goes into it. So I like to think about this as just a general cycle of problem solving if we start up here at the top. So the first thing that we want students to do when they set up and solve word problems is to read the problem. Does every student here at the Schenck School read a word problem before they solve it? No. All right. Yeah. And thank you for just saying no. All right. And that could be a barrier for some students, whether students have reading difficulty or they just skipped that step. A second thing that's adjacent to that is understanding the vocabulary in the word problems. Now, some of that might be math vocabulary, more, less, altogether, share, fewer. Some of it might be chocolate, cupcakes, sharks, dolphins, Mrs. Thompson. Like, if I don't understand that vocabulary, it might prohibit me from being able to access this word problem. And then, what information do I need? And that's not only numerical information, like, oh, I do need 26. I also know that that tells me about $26 or 26 dolphins or whatever it might be. And then some word problems, you have to ignore some stuff. So there's extra stuff in there. How do I ignore the irrelevant information? And also in some word problems, there's information that's embedded within charts and graphs. Not all word problems, but some. But if I start right here with my word problem cycle, and I move all the way over here, it could be to this point, I have not picked up my pencil yet, or stylus, or whatever students are using to solve. And so really, the hardest thing about word problem solving is the understanding and the setting up of that. Once students have a good understanding of the problem, then they have to make a plan. What are they gonna do? And that might be with manipulatives, they might do something with drawings, graphic organizers, and then they have to do some type of math, or usually some type of computation. Now, some of your students might have a hard time with this, or they might have a hard time with this. But what's pretty common in the world that I work in is that we have students that have a hard time with this whole thing. And so as we design our word problem instruction, we have to think about how do we help students read the problem? How do we help them understand the vocabulary? How do we help students identify that important information? How do we help students make a plan? And how do we help students with the computation? So there's a lot that goes into problem solving, and that's why it's probably like many teachers' least favorite thing to do in math, because it's a very complex task. Now, ineffective strategies. There's just two I'll just briefly talk about. One I've already mentioned. One thing that is not helpful is to take keywords and tie them to operations. That usually revolves around something that looks like this. Have any of you ever seen something that looks like this? I'll cover my eyes. Okay, all right, I won't. Yeah, all right. Maybe hanging in your room. We might remove some of these tomorrow, okay? This is a long time ago. Okay, good. Okay, good.
In this building.
Okay, good. Not in this building. Jenna made sure of that. This is a keyword poster where words or terms are organized by operation. Now, over here in this word problem, I'll just kind of want to quickly go through this. There's the word total, and I'll just tell you, if you add all of these numbers together, because total tells you to add, you will solve this problem correctly. But here is also where the word total. If I add 4 and 5, I will not solve this problem correctly. And here is the word total. And if I add these numbers, I will not solve the problem correctly. So while total sometimes means addition, sometimes in this example, total means multiplication. And sometimes in this example, total means you're given the total and you have to find another one of the parts of an unknown equation. And the thing about these keyword posters is they're very easy to find. And I will suggest, and I know we do have some parents and caregivers in the room, even if this is not hanging at school, we are finding more and more examples where this is being printed off at home. And so we have to not only help think about, well, teachers should not be using this, but also parents might be like, oh, let's just print this out to help with homework. Well, it's not really an effective strategy. And here's some data as to why. So we have gathered a large number of standardized test released items across grades 3 through 8. And I'm going to get into this in a few minutes. We organize them by schema or concept. But in turquoise here is the percentage of the time that we saw a keyword in these word problems across grades 3 through 8. And I would suggest these percentages are quite high. So 96% of the time in a problem where things are put together, I'm going to see one of those total or addition words, or it might be total put together in all or something like that. 100% of the time in difference problems. So students see keywords a lot. In orange is, can I use that keyword and solve the problem correctly? If like, oh, total means to add or share means to divide. Well, here's the percentage of the time that keywords work for single-step word problems. And for some types of word problems, it's not terrible, 70 or 80% of the time. But for other types of word problems, keywords only work 28, 30, 50% of the time. But where the keyword strategy just spectacularly falls apart is with multi-step word problems. So here is the percentage of the time that a keyword appears in a multi-step word problem. And here is the percentage of the time the keyword will work. And so by the time we get to 3rd, 4th grade and multi-step problem solving, especially as we go into 5th grade, 6th grade, and then that's what they're doing all the time, the keyword strategy is like insanely ineffective. And so if kids have learned early on, oh, when I see total, that means to add, or when I see share, that means to divide, that works in 1st or 2nd grade fairly often. But by the time we get to 4th or 5th grade, that doesn't work at all. And then we're having to undo this thing that kids like latched onto because that worked, that helped me solve the problem, but it's actually a totally ineffective strategy. The other thing that's very ineffective, and this is a word problem practice thing, is presenting problems just by operation. So if I gave this to all of you, what would you do? Just add everything. You would add. All right. You needed 1 second to tell me that. So question, are you going to read these stories? No. What are you going to do? Just add the numbers. Add the numbers. I love this. This is what we refer to in my research lab as number pluckers. They pluck the numbers and they add them together. Do you have any students that are number pluckers? Yes. Yeah. All right. We got, like.
For everybody with ADHD.
Yeah. Well, and because the first also 25 problems that they ever solved, probably first 25 word problems you ever solved, you took this number, and what did you do? You added it. And so in many ways, by the practice that we engage students in, we're conditioning them to not be good word problem solvers. But hey, what are you going to do here? Subtract, multiply, divide. This is a 7th grade example. You do not have to read these problems. Just take the larger number and divide it by the smaller number. But when I think about problem solving in the real world or on assessments or however your students are problem solving, they have to read these problems and they have to decide for themselves whether they're going to divide or subtract or multiply. And I'll even press the teachers tomorrow. There's a lot of problems that are not always subtraction problems. Some kids might add, some kids might subtract, and both of those approaches are valid and viable. And so we don't want to pigeonhole students into saying, you have to do this operation, because there's often another way that they could do it. So we don't want to do that either. So that's kind of depressing, because those are the easy things to do, all right? So the harder things to do are these two things, which I'm just going to do a very brief overview, and then I'm going to work with the teachers tomorrow for about an hour and a half on this in each of our morning and afternoon groups. So the things that the research has showed us that are really important to do for word problem solving are to teach students an attack strategy. So this is a metacognitive strategy for working through the word problem. And then to teach students about those schemas. Conceptually, what's going on in these stories? Because across grades K through 5, there are 5 schemas that students see regularly. And it is very hard to find a word problem that doesn't fall into one of those 5 schemas. So just as we help students recognize, oh, that's a story where you put things together. If they've solved that story before, then they know how to approach solving a story where they put things together. So attack strategies are strategies that look like this. Many times they're mnemonics, they do not have to be, but they really just give students this general process for working through the word problem story. These are 3 of them. There's about 25 different attack strategies out there. The 3 most popular that we see used are solve, R-cubes, and we often use UPS, check. And then I'm not going to ask you to share your favorite attack strategy. I'll ask the teachers tomorrow that. But then we get into the schemas. And so I said there's 5 concepts that we see a lot across grades K through 5 in not just word problem solving, but actually just in math. And so if we can help students recognize, oh, this is a story about a total, or this is a story about equal groups. If then they've practiced equal group stories, or maybe they have a visual, or they've worked with like an equation that represents equal group stories, then it makes solving a story with equal groups a lot easier for students. And so I'm just going to give a very brief example of some of these, just to give you an idea of what these schemas might look like. So when students learn to add, one of the ways that they learn to add is they put things together for a total. So here I'm bringing all of these squares onto this mat. 2 plus 3 is 5. But another way that students learn to add is to start with 2 and add on. So here I have 2, 3, 4, 5. Now with those 2 ways to interpret addition, they directly map onto word problems. So one way that students might think about a word problem is in this total interpretation. Laura saw 4 cardinals and 5 blue jays. How many birds did Laura see? But then we also have this other way that we could think about word problems with addition. Lizzie had $4, then she earned $5 for cleaning her room. How much money does Lizzie have now? In one of those stories, parts were put together for a total. In this story, we had one amount that increased to a new amount. I'm not going to ask you guys to do that, so sorry. Unless you want to in your brain, just tell yourself a total story. But then when we get to subtraction, we teach subtraction in 2 ways. One is subtraction is taking away. So here I have these 5, and I'm taking away 3 things, so I have 2 that remain. But another way that we interpret subtraction is thinking about the difference between 2 amounts. And those interpretations of subtraction directly relate to the word problems that students are going to see in that grade level and in subsequent grade levels. So what about a story like this? Annie had 9 cookies, then she ate 2 of them. How many cookies does Annie have now? There we have this subtraction or taking away of the cookies. But that's a different story than this one. Madeline has 9 apples, Katie has 2. How many more apples does Madeline have? Or the question could be, how many fewer apples does Katie have? There, we're comparing 2 amounts for a difference. So what we can see is that in word problems, if students can recognize, oh, this is a story where we have a total, this is a story where we have a difference, or this is a story where we have a change, they've solved a change story 10, 20, 30 times. It makes it just a lot easier to solve that type of word problem. So eventually, and this is what we'll be working on tomorrow, we get to the point here where we get to ask students to do the attack strategy and the schema stuff all at the same time. So first I see this word problem and I immediately think, I've got to attack it. I like to use the attack strategy of UPS check. And then we understand this problem by reading it. So I read, Allie delivered 12 boxes of cookies on Friday, 25 boxes of cookies on Saturday. How many boxes of cookies did Allie deliver? I would ask students, what's this problem about? What would you tell me the story is about? Boxes of cookies, yeah, and Allie delivering the cookies. So I might underline boxes of cookies. I'm only going to underline it once. Could I underline it every time I see it in the story? Sure. But now I've underlined it once to just focus in on boxes of cookies that she's delivering, and I have a general understanding of the problem. And then when we get to make the plan, I would ask students some questions by schema. So I would ask you, is this a total problem? Are parts put together for a total? And I would hope students would say, yeah, Sarah, it is, because we have cookies on Friday, boxes of cookies on Saturday, and we're figuring out that total. So once I do that, maybe I draw a total graphic organizer, a total equation, and now my plan is made. I will solve this problem as a total problem. And then as we go back and set up and solve this problem, I'll go back and reread. I'll fill in the numbers that I need. Maybe I put them into an equation. Maybe I put them into a graphic organizer. But then ultimately, I want to solve the problem. It's always helpful to write a numerical response and the label or the unit. And then students have solved it. And then the very classic thing we always ask students to do in math, go back and check your work. And so we will get into this tomorrow. It'll take about 30 minutes to get us up to the point where we would help students with these total problems. But I just want to give you an idea of how these schemas can be helpful, because we see total problems all the time. And sometimes it's with 12 and 25. Sometimes it's talking about adding 2/3 and 3/4. Sometimes it's working with positive and negative integers. The schemas stay the same across grade levels. The numbers increase in complexity. But if students can recognize that concept or that schema, it just makes word problem solving a lot more digestible. We will often ask students, how many word problem types do you think there are? And they'll be like, thousands, millions. And I'll be like, there's 5. And I think that's always like, bring it back to that. And so just similarly in multiplication, we have different ways to interpret multiplication. Sometimes we talk about multiplication as equal groups. That equal groups can also be within an array. But we also have a multiplication on a number line where we have a set multiplied a number of times. And probably you know where we're going with this. This plays out in word problem solving directly as students have learned about multiplication. So I could have this story about Tierney has 3 boxes of crayons. There's 8 crayons in each box. How many crayons does Tierney have altogether? That's a conceptually different story than Elizabeth has 8 stickers. Allison has 3 times as many as Elizabeth. How many stickers does Allison have? And so same thing with division, different ways to think about division. This is sharing or division in groups. And then guess what? There's word problems. This one's with sharing. This one's with putting things into groups. And so everything that students do related to the operations directly relates to word problem solving. And what we need to do is we need to emphasize that schema or that concept so that students see the regularity and the consistency across these different word problem types. This is just an example. I'm going to go through this. I'm going to just blow through this one. But I'll just, setting it up and solving it in the same way. Attack strategy. Here's the schema. I underline and check off stuff. And so everything I did for an earlier word problem, I can also do for this later word problem as well. And so to wrap up, when we think about what's important for support in math, there's 5 things that I would ask you to be considering, whether you're working with your child or working with students. So every day in math, how are you helping students understand the vocabulary of math? Every day in math, how are you bringing in representations so that students have some understanding of what the math means? That might be manipulatives, drawings, tools, symbols, gestures, acting things out. There's a lot of different representations we can use. Every day in math, how are we modeling and practicing? Students learn a lot from the model, but students learn math through practicing. So practice is important. How do we build fluency? So once students have acquired some math knowledge, it's important to build that fluency, that ease and accuracy. There's a conversation for another time, but fluency isn't only memorization, but it is a lot of ease and accuracy. And then every day in math, how are we supporting students' word problem solving? At kindergarten, if I'm working with cubes and I'm asking students to take 2 cubes and 2 cubes and put those together for a total, and I might not be thinking I'm doing word problem solving, but I'm laying the word problem solving groundwork at that time. When I'm saying, oh, let's put those cubes together. What happens if you have 2 cubes and I add on? Right there, I've talked about total problems, and right there, I've also talked about change problems. And so word problem solving is at every grade level. We don't want to just start at grade 3. So a few resources if you're interested in some of this. My colleagues and I have written an intervention around word problem solving. It's free and downloadable. We have a new version for multi-step word problem solving coming online soon. We were in the video recording studio 2 days ago working on that. This is a total difference change, equal groups, and set intervention where you can use this with your students and teach them all about word problem solving. And it's free at pyromathequationquest.com. We have a project where we support teachers with their math teaching. So at our Math Spiral website, you can find tons of downloadables, word wall cards, lots of like UPS check posters for problem solving, lots of fluency activities, lots of things about explicit instruction in math. So that's another resource there as well. And then we do have a video recording studio in my office building where we do make a lot of videos about math. You may have seen a few. I know one of you already told me you saw some of them before. That's from our Project Stare YouTube channel. And we are right now making some new videos that'll be online soon. And then if you ever need some free materials, you probably have a lot already here in Georgia, but we made these for Texas, but they kind of apply, math applies everywhere. These are 23 free and downloadable modules that are specific to math content. So if you have a kid that needs to practice subtraction with rational numbers, there are 11 different problem sets, all with vocabulary cards and all with free lesson guides. So you can download those and access those. And then I've had the opportunity from the National Center on Intensive Intervention to put together this free math course about teaching of math. And then some of my other favorites. I love this What Works Clearinghouse practice guide. We wrote a companion piece of that practice guide for Australia. These are some of my favorite virtual manipulatives. And then that brings us back to me, which I wanted to leave about 10 minutes for questions, and I just did it. Wow, so that was great. Thank you. Yeah, thank you. So if you do, I'll send this to Jana and colleagues, but if you want to have this slide deck, I'm happy to share it with you. You can follow this QR code or that bit.ly. Drop your email address in. I'll send it to you later tonight. That's my email address. I'm on all the social medias and share a lot of stuff about math things. So I'd love to continue the math conversations. Many of you have to do that with me tomorrow. But some of you, if you would like to continue the math conversations, and I'm always happy to chat about what's going on with your student, what's going on in your classroom, or what's going on with your school, because I'm kind of a big geek about math. So yes. So thank you very much. And we have a few minutes for questions. So what would you like to know or talk about in terms of math? Not everybody at one time. Yeah. So
I'm curious about the multi-step math problems with schemas. Like sometimes there was like different, almost like smaller schemas within the large schema.
Yeah. So we're doing multi-schema stuff right now, and we're working in grades 3 and 4 and kind of into 5. And I can get into some. Are you going to be there tomorrow? Yeah. Okay. We can get into some real particulars. We see in Texas there's about 5 combinations that occur very frequently: total and difference, total and equal groups and equal groups, equal groups and like kind of an equal shares. That's another equal groups. And so then we teach students to identify those two schemas, and we have a whole way that we set that up. So I've got like one page on multi-step word problems tomorrow, and we can do a few examples of that. If we really want to get into multi-step word problem solving, it's like a full day on single-step schemas, and then it's like a full day on multi-step schemas. But we have found that students, it's not easy, but if they have that first schema knowledge, it's much easier to transition into the multi-schema problems. Yeah. So I'll put a few things in tonight to bolster that section. Yeah.
Your slide up there with basically the stat on the improper word that fooled there.
Uh-huh.
And I'm curious because I'm just thinking drawing, as somebody just wanted to solve it.
Yeah.
If you saw that connection, and especially if you had a multiple choice test, you would tend to be lured there.
Oh, totally.
Is there any data that says if you don't have the multiple choices, kids are more likely to just use it to solve the answer, or has that changed any techniques of like let's choose multiple choice for a while?
I don't know if that's related to multiple choice. So, but we have about 1,400 of these released items, so I could probably find the answer to the question, but I'll have to think about it. But where I want to go with answering your question is the people that write these questions, whether it's for a state assessment, whether it's in a textbook, they know that kids use the keyword strategy. And almost every time you see total in a word problem, it does not mean to add. It's almost like do the opposite of what you think. And so people are writing these problems to trick kids. And it's like if you see share, it often doesn't mean divide. If you see per, it also often doesn't mean that you're going to divide. but your keyword poster tells you that it does, right? So there is a lot of trickeration there, which I am not a fan of, but I think that that's where it also goes back to understanding the vocabulary. Like, do you know what per means, and do you know what per means in this situation? Because there is a word problem where you see per and you will divide, but there also is a similar word problem where you might end up multiplying or doing some type of repeated addition or something like that. Yeah. Yeah.
I'm curious about, so my job, we work with districts and training in science of reading and all that. Yeah. And right now we're in year 2, which is all comprehension, and all of a sudden a light bulb went off for districts like, oh, we should have not just been only training ELA, we should have been training math teachers this entire time in vocab.
That would have been nice. Yeah.
And so and that just got me thinking, like, if there's any data or research in, like, I was saying to you earlier, like, if a teacher doesn't know how to solve these things or the language of these, like, they're not going to be able to teach kids these things. So if you know any research or data about training teachers and understanding these different schemas and sets of things.
Yeah, so I was talking to Mike about this earlier, just a little bit of a step back, and then I'll come back to the schemas. So training of math teachers is a little bit different than training in reading. And the reason why is that, and this is not to every teacher out there, but for a lot of particularly elementary teachers, not only are you teaching them how to teach math, but you're also teaching them math. And you're not often teaching adults to read. You're just teaching them how to teach reading. And so that's like an additional component. And so often if I'm talking with principals in districts, and they'll be like, oh, we're gonna have like 2 days of PD about reading and a half day on math. I'm like, hey, let's add more math in there, because teachers need more time to develop their own math knowledge. Even just like, how do you teach counting? How do teachers interpret, not the equal sign as train tracks, right? So that we need to make sure that we are providing as much, if not more, training in the teaching of math, because teachers need a lot of that support. And then as it comes to word problem solving, so there's not really any textbook series that's really doing a great job on word problem schemas. So most of the efforts are independent. That's why we create all these materials and allow people to use them for free. And so when we do a training, I usually will do like a 6-hour word problem training, and then I also like to always come back later in the year. But I think it's just increasing teachers' knowledge so that then they can apply it. And it starts early. You're using the bears. And do you realize, like, you have to explain putting the bears together and adding on to the bears, or taking away from the bears and comparing the bears, right? That's directly related to word problem solving. And so we just have to build up teacher knowledge in that area. And we're just going to do it one day at a time. So, yeah. Tomorrow is one of those days, And I'm in Boston for a conference I'm on Saturday, and I'll be talking about schemas there as well. Yeah, a lot of schema stuff from me. Yeah.
So I just have to tell you that I was like all excited to work with this little girl and do the whole part schema. And I said, okay, do you know what whole and part are? And she goes, yeah, part in my hair. I was like, oh, so we're gonna have to go back. Before we even started.
I think, Janet, it's like a perfect example of you say part and I say part, and we're thinking totally different things. Yeah. And I wouldn't even think about the part in my hair. Yeah, exactly. Or like often when we start doing fractions, like whole is like digging a hole, right? And it's like spelled differently, and I see it as different, but the students have just a totally different interpretation. And if that's where we're starting, it's going to be very hard to find a common pathway and actually learn some math together.
Which is why you have to start with the vocab.
Because
then you find out
that's
at
right.
the end, like, she's thinking about her hair.
Yeah, and that's where it's like on that instructional platform, I'm like, that is the first thing that we need to think about. I mean, first we need to think about what are we teaching today, but I think that, like, okay, if I'm teaching addition of fractions with unlike denominators, what is the vocabulary that's important for that? That should be the absolute first thing. And then what strategies and representations am I using to teach that? And then how am I going to model and practice? And then finally, how do we build fluency with that? And how do we get students to practice that in problem solving? So I think that instructional platform follows a pretty linear pathway in terms of where we start to where we should be. as you leave here today, I brought in some goodies if you want to take them, and I have more copies than I need, so take as many as you want. But with the Meadows Center at the University of Texas at Austin, we provide a lot of free resources for groups. So this is a little 4-pager about 10 key math practices for elementary schools. And then this is the secondary, the middle school and high school version of that. It's just 1 page, but still also 10 key practices there. So you're welcome to take those and share them with your friends. And then I'll stick around and answer some questions. So thank you so much for the opportunity to be here tonight. And yeah, thank you. And continue the math conversations. Thank you.